Hi guys, welcome back to my YouTube channel Learn Physics Better with Blessing, a channel set up with the aim of helping students who are finding it difficult to understand the subject physics. We started one of the basic topics in physics, which is motion, and we've treated definition of motion, causes of motion, and types of motion. So today I'm going to continue on another aspect of motion, which is relative motion. We define motion as a change in position of an object. It is thereby impossible to determine the change in position of an object if there is no point of reference, or we'll just assume the object is at rest. I'll give an illustration explaining that. I'm going to give an illustration using this table and this marker. We'll place this marker here. We'll target this point. Tag this point A, and then move it over to the center of the table. Let's start that place, point B. If someone just walked in now, the person would think this marker has been here all through, not knowing we moved it from point A to point B. But we know this marker changed position because there's a point of reference. That is, the point of reference here is the point A to point B, which is the center of the table. I'll give another illustration for better understanding. A man sitting still on a back seat of a moving bus has a speed with respect to the earth. He has a speed which is the same as the moving bus. Let's say the bus is moving at 100 km/h. With respect to the earth, the man is also moving at this speed. If he now moves towards the driver, let's say he moves towards the driver to give the driver money. Just let's use our Nigeria setting. There's no conductor who wants to give the driver money. If he now moves towards the driver at a speed of 5 km/h, 5 km/h. With respect to the earth, his speed has increased. So it is no longer 100 km/h, it is now 100 km plus 5 km/h, which is 105 km/h. 105 km/h. With respect to the earth now, his speed has increased. If he now gives, okay, now let's come back. If he has given the driver money and is coming back to his seat, with respect to the earth, he's coming back to his seat with the same speed of 5 km/h. With respect to the earth, his speed has reduced. That is, it is no longer 105 or 100. It is now 100 km/h minus 5 km/h, which is 95 km/h. So with respect to the earth, as he moved towards the driver, his speed increased. As he's coming back to his speed, as he's coming back to his seat, his speed decreased. This is with respect to the earth. Now, with respect to the bus, the man's speed at both instances were the same. That is, when he was moving towards the driver and when he was coming back to his seat, the speed at those instances were the same, but the direction was opposite. That is, he was moving forward and coming backward. He was moving front and back. That's opposite direction, but the speed were the same. But with respect to the earth, his speed were different at those instances. As he was moving towards the driver, his speed increased, but as he was coming back to his seat, his speed reduced. So you see now that point of reference is very, very important. And the point of reference in this illustration is the bus and the earth. In my next video, I'm going to start another interesting aspect of motion, which is terms used in motion. And these terms include speed, velocity, distance, displacement, and so on. Subscribe and turn on your notification button so you get the notification when I post. Please don't forget to like, share, and comment, and also subscribe. Thank you. Stay safe as always.